Yeah, and now that we talked a lot about image data and its challenges, let's get back to the convolutional neural networks and see how convolutional neural networks work. And we will start here with a convolutional neural network architecture overview. And yeah, because saying convolutional neural network all the time is a little bit tedious, we will also abbreviate it with ConvNet or CNN. So in contrast to multilayer perceptrons, CNNs take locality into account, as we have seen in the previous video. CNNs can help us with challenging problems when it comes to image data. So here consider the handwritten digit 1 as a grayscale image. So what we want is a certain level of invariance. So that means that the image can still be correctly classified even if it's a little bit off-center, or if the image is a little bit scaled in terms of being bigger or smaller. Or of course if the image, the digit here, is a little bit rotated around its axis. And ideally, CNNs should also learn to ignore parts of the image that are not relevant to the classification task at hand. So for example here, if we want to classify the cat in this image, the network should be able to ignore the background. And so yeah, CNNs are not perfect, but CNNs at least aim to address these issues that we just highlighted. So a typical CNN architecture looks like as follows. We have the convolutional layers here at the center, and the convolutional network layers, they are responsible for the implicit feature extraction. And this is also one of the main reasons why we sometimes refer to deep learning as representation learning. Modern deep neural networks are actually representation learning networks. So typically, following the convolutional layers, we then have these fully connected layers, the multilayer perceptron part that is responsible for the classification. So this was one way of looking at a convolutional neural network architecture. I will now show you a different way of drawing a typical CNN architecture. So in this architecture, we have again the convolutions here, the convolutional layers, and we have these fully connected layers, the multilayer perceptron part to the right. So what I've highlighted here are the learnable or trainable layers in the neural network architecture. The convolutional layers and the fully connected layers have weight parameters and bias units that we can train. The other parts in between, the pooling layers, and we will discuss them in more detail later, they don't have learnable parameters, at least not the typical pooling layers. Yeah, and since these drawings can be a bit abstract and hard to understand if they are new to you, let's actually look at a typical CNN architecture in PyTorch. So when I implement CNNs in PyTorch, I like to structure them in two parts. I usually have my convolutional part, which consists of the convolutional layers and pooling layers. And I have the classifier part, which consists of the fully connected layers. So this classifier part is essentially similar to the multilayer perceptrons we covered in the previous units. And yeah, we then connect these two parts in the forward method. So in this video, we saw a big picture overview of the CNN architecture. In the next video, we are going to talk about the convolutional layers in more detail.